Hello everyone! Today we're going to study the cycloalkanes, which are a homologous series of saturated cyclic hydrocarbons. As the name suggests, cycloalkanes are very similar to the alkanes that we have already studied. The only difference is that cycloalkanes are arranged in a cycle and alkanes are arranged in an open chain. But both of them are saturated, meaning that there's not going to be any double or triple bonds in the structure, only single bonds. So each carbon atom will have its 4 bonds. Carbon atoms always have 4 bonds, we know that. But each of those atoms is going to be linked to either other carbon atoms or completed with hydrogens. No double or triple bonds, okay? Only single bonds. The general formula of the cycloalkanes is CnH2n, which means that we're always going to have twice the number of hydrogens as we have of carbons. So we'll have 3 carbons, 6 hydrogens, so C3H6, C4H8, and so on. The cycloalkanes are used as fuels and solvents, and they are insoluble in water. Let's have a go now at naming the cycloalkanes. So it is very easy. It is just using the same roots that we have seen for both alkanes and alkenes. So for 1 carbon, we're going to have meth, 2 carbons, F, 3 carbons, prop, 4 carbons, bute, 5 carbons, pent, 6 carbons, hex, 7 carbons, hept, and 8 carbons, oct. These are all the roots that we need to know. However, we may notice that it is impossible to make cycloalkanes that have only 1 carbon or 2 carbons, because that would be a line or just an atom. So the smallest cycloalkane that we can have has 3 carbons. So that means that actually we're not going to use any of those in cycloalkanes. So we would start our 3 carbons. We're going to complete these. So each carbon has its 4 bonds. So we complete with hydrogens. And we're going to try and name it. The first thing that we have to know about cycloalkanes is that they start with the word cyclo. So this is going to be a cyclo. It has 3 carbons, so a cycloprop. And because it is saturated, it is an alkane, it's going to end in ane. So we have cyclo, prop, 3 atoms, ane, a saturated molecule, so cyclopropane. Let's try, for example, 6 carbons. We complete the carbons, so each of them has 4 bonds with hydrogens. And we name it cyclo, 6 carbons, hex, no double or triple bonds, only single bonds, so ane, cyclohexane. Cycloalkanes have the same general formula, CnH2n, as alkenes, and we're going to try and see why in a second. So if we try to make the general formula for cyclopropane, we have to count the carbons, 1, 2, 3, so it would be C3H, we know it's going to be double, so we know it's going to be H6, but we can count them, 1, 2, 3, 4, 5, 6 for cyclopropane. If we look at cyclohexane, we have 1, 2, 3, 4, 5, 6, C6, H12, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And we know that these are saturated carbons. However, the general formula is different from alkanes because if we remember, for alkanes the molecular formula, the general formula, alkanes general formula was CnH2n plus 2. And for alkenes, it was the same as for cycloalkanes, CnH2n. And let's try to see why. Let's take propane or cyclopropane and all of the analogues. So the analog of cyclopropane in the alkane would be propane. So we have C, H, 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 C, C, H, 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 H. So we have all of the carbons linked to other 4 things. And now let's draw the alkene analog, which would be propene. So we have one of the carbon with a double bond to another carbon, meaning that when we complete with the hydrogens, we can only put 2 at the end because it already has 2 bonds here. And for this middle carbon, it already has 3 bonds, 1, 2, 3. So we can only complete with 1 hydrogen. This carbon in the extreme still has his 3 hydrogens to complete the 4 bonds. 1, 2, 3, 4 bonds. And this is propene. So if we look at the 3 molecules, propane, propene, and cyclopropane, let's analyze their general formulas. 1, 2, 3 carbons, C3, 1, 2, 3, 4, 5, 6, H6. As we see, and we already knew before, alkenes and cycloalkanes have the same general formula. However, propane, as we know, is going to be slightly different. 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8. The reason behind that is that propane has 2 carbons in the extremes that are only linked to one other carbon. Therefore, they have to be completed with 3 hydrogens to reach to the 4 bonds. So 1 carbon, 1 hydrogen, 1 hydrogen, 1 hydrogen, and the same on the other side. But this is not true for neither propene and cyclopropane. So if we wanted to make cyclopropane out of propane, the 2 carbons in the string would have to be linked together. And this bond doesn't exist. This is just a fictional bond to show you how these 2 would be tied together. So it would be this bond here. Okay, we have carbon 1, carbon 2, carbon 3, carbon 1, carbon 2, carbon 3. So when we transform that, if we linked it together, this carbon 1 would have 5 bonds. 1, 2, 3, 4, and 5. And the same would happen with this carbon 3. So in order to form the cyclopropane, it would have to lose 2 hydrogens. And now it would have the 4 bonds in each carbon. So 1 bond, 2 bonds, 3, 4. And the same here. So that is why in the molecular formula the alkanes have these 2 extra hydrogens, because they have 2 extreme carbons that need 3 hydrogens to complete the 4 bonds. In the case of propene, which has the same general formula as cyclopropane, those 2 extra hydrogens have been lost because we have a double bond. So instead of having a hydrogen here, I'm going to draw that tentatively and a hydrogen there. That would be 5 bonds again, 1, 2, 3, 4, 5, and 1, 2, 3, 4, 5. So it loses these 2 hydrogens here and forms the double bond, and hence we have the same number of carbons and hydrogens for the cycloalkanes and the alkenes.